Calculating reliability for multiple choice question exam in both SPSS and Excel software. 3 different methods will be used to test reliability. The first method is Kuder-Richardson Formula 20, KR-20. The second one is the Cronbach's alpha formula using Cronbach's alpha formula. The third one is based on ANOVA table to calculate the reliability. All these 3 methods will be performed in both SPSS and Excel. 3 methods for testing reliability of multiple choice question exam paper in SPSS. The first method is Kuder-Richardson Formula 20, KR-20 to test reliability of an exam. The second method is Cronbach's alpha formula, and the third method is based on using the ANOVA table in SPSS. Reliability test for multiple choice question exam in SPSS using Kuder-Richardson Formula 20, KR-20. The test measures the internal consistency of items and score consistency. If a group of students repeat the same exam with the same questions on 2 different occasions, the scores on both occasions for each individual student are similar, and that indicate score consistency. And the formula to calculate that, the KR-20, is equal to K divided by K minus 1. K stands for the total number of questions, and then multiplied by 1 minus summation of P multiplied by Q. P stands for proportion of the correct answer, and Q proportion of the wrong answers for each question, divided by the variance for the total score. Here I have a data from an exam result for 10 students answering 15 questions, multiple choice questions, and the score for each question was recorded as 1 for correct answer and 0 for wrong answer. And to calculate the reliability value for this exam, we need to do a KR-20, KR Formula 20, and use this formula to obtain the reliability value for this test or exam. There is no straight command in SPSS or function that can calculate the KR-20, and we had to calculate each component of the formula one by one. So the first step is to calculate the total score achieved by each individual participant or student. And the way to do that is to click on transform, then click on compute, and in the compute window we're going to generate a new target variable. I'm going to call it total score. And in the numeric expression we are going to add all the values achieved by each student for all the 15 multiple choice questions. So we select question number 1 and move it to the box in the numeric expression, then add the plus sign, and then we do the same thing for question number 2, and then we add the plus sign, and so on until adding all the questions from 1 to 15. Going to add 13 here, and then add 14, and finally plus sign, and then 15. And if we click on OK, a new column will be generated or variable called total score, and the value in it is the addition of all the scores for each individual participant. And I'm going just to decrease, if I click on the variable view and decrease the decimal to 0, so I get numbers of total score in this format. Now, once we have calculated the total score, the next step using the equation here is to calculate the variance for the total score. And to calculate the variance for the total score is to click on Analyze, then scroll to Descriptive Statistics, Frequency, click on Frequency, and we're going to move the total score to the box variables, and in the statistics we're going to select in this square here, click on the variance to select the variance for these variable or these data. And if you click on Continue and then click on OK, tables are generated. In the first tables, the variance is calculated for these 10 participants, and the variance for the total score is 24.8. If we double click on that and then select this, right click, copy, move it to here, and we're going to paste this here, and I'm going to reduce the size. So now we have calculated the variance for the total scores. The next step is to calculate P, Q, and summation of P and Q. And to do that, first we need to transpose the data. To do that, we click on Data, scroll down to Transpose, and then I'm going to select all the data and move them into the variable section, and then click on OK, and the data are transposed in a way that the questions now in a row and the student cases are in column. And I'm going just to do some editing here to make things more neater. I'm going to decrease the decimal to 0 for everyone. I'm going to select, copy, and then paste to make them all 0, and I'm going to make all the data centered. So I'm going to select, copy, and then select, and then paste for each one of them. Select again, copy, right click, paste, right click, paste. And we're going to keep the things as scale for all the data. So we're going to make the data scale. So we have all the data in scales, and I'm going to reduce the width of the column to size number 4, and then copy this, and then select, and then paste to make them all four. So if we click on data view here, a little bit neater. We're going to change also the label for the variable. Instead of keeping it as variable, I'm going to label it as student. So the way to do that is to select these 10 variables and then click on Control F for find and replace. So I'm going to click on replace, and then I'm going to type var 0 and replace it with S, and I'm going to click on replace all and then close that. Again, we can see here, if we click on the data view, that the questions are in rows and the student or cases or participants are in column. Now the next step is to calculate the P. P is the proportion of the correct answer, and the way to calculate that is to click on transform, compute variable, and in the window for compute variables, we're going to call a new variable, generate a new variable and call it P. And to calculate the P is in fact is the mean. Since we're calculating the proportion of the correct answer, it means the means, which is the sum of all correct answer divided by the total number of students. Here we have 10 students, and to calculate the mean for that, we click on all and then look for statistical, and then in the statistical function, select the mean, drag the mean and place it in the numeric expression. In the numeric expression, it has a name, a mean, and followed by a bracket, and we need to insert each individual variables here for S1 into the between the brackets one by one, and each one separated from another by comma, and we need to do that for the whole 10 cases or students. And so we need to make sure that we keep the comma between after each variable. And then another comma after number 9, and then this is 10. If we click on OK, a new variable is generated for the proportion of the correct answer. We're going to ignore this value here for the total. So we can see here, this is the proportion for the correct answer achieved by individual by student for each individual question. To calculate the Q, which is the proportion of the wrong answer, click on transform, compute, and then reset this, and we're going to generate a target variable, call it Q. And for the Q, we're going just to use the formula, which is 1 minus the value that we had already calculated for P. Instead of calculating the wrong answer for each question and then divide that by the total number of the students, we are going to use this formula 1 minus P, drag the P here and click on OK. A new variable is generated, which is the Q for the proportion of the wrong answers. Now the next step is to multiply the value of P with Q to generate a PQ. And the way to do that is to click on transform, compute variables, reset, and then we're going to do multiply P by Q, call the target variable PQ, and to do the multiplication is to select the P variable, then you select the multiplication symbol, then select the Q variable. Click on OK all the P and Q variable for each individual question here is calculated. Now, following this equation here, we have managed to calculate the variance for the total score, the multiplication of P and Q. Now we need to calculate the sum of these P and Q. And the way to do that, if we are here in Spss, click on Analyze, then click on Descriptive Statistics, then click on Frequencies. In the frequencies, we are going to select the P and Q and drag it into the variable. And we click on Statistics, and we're going to select the sum. So we're only interested in doing a sum, finding out the sum for the P multiplied by Q. The sum here is 3.42. If we double click on this table and then highlight and select and copy, and we're going to transfer this and place that here in this area, so for the value of 3.42. Now we had calculated all the necessary components of the KR-20 equation or formula. The next step is to use a calculator to find out the KR-20. And if we click on calculator, and in the calculator here, I am going to first of all to determine the K. The K is the number of questions in the exam, and here we have 15 questions. So K is 15, and the K in this one will be 15. So it is 15 divided by 14. And using the calculator, I'm going to divide 3.4 over 2.4, 24.8. To find the product for that is to type here in this calculator 3.42 divided by 24.84 equal 2.1. This value is equal to 0.137. So I'm going to add here 1 minus 0.137. Again, if we go back again to the calculator, 0.137, so we're going to use just only 3 decimals, 0.137, and I'm going to subtract this number from 1, so minus 0.137 equal, that number will be equal to 0.86. So it will be here, generate another number here, it will be 0.86. So we need to multiply 0.86 by 15 divided by 14. And we're going to do that using this calculator. So we multiply this by 1.5 and then equal, divide that by 114, then click on equal, and we have here a value of 0.92. So eventually the KR-20 for this exam, KR-20 is equal to 0.92. So this indicates that the test or the exam is 92% reliable. If we go back again here into the Spss, these 15 questions answered, multiple choice questions answered by the 10 students, this exam is 92% reliable, and the KR-20 value ranges from 0 to 1. 0 means that the exam is unreliable. 1 means that the exam is extremely reliable and extremely excellent. So this is the way to calculate and determine the KR-20 reliability for exam and test that only contains multiple choice questions. And the way to do that is to use the KR-20 formula by calculating the number of questions in the exam and calculating the sum of P multiplied by Q. P stands for the proportion of correct answer, Q for the proportion of wrong answers, divided by the variance of the total score. And from the value of the KR-20, the exam or the test will be labeled or classified as either reliable or not reliable. Reliability tests for multiple choice question exam in Spss using the Cronbach alpha formula. Reliability test measures the internal consistency of items and the scores consistency. If a same group of students repeated the same exam with the same questions, multiple choice questions, at different occasions, their scores in both occasions will be similar, i.e. the exam or the test will be consistent and the scores will be consistent, and the exam or test will be reliable. So there is a consistency of scores between those two occasions. So reliability test based on Cronbach alpha assess the exam and the test based on the equation below to determine the reliability of the test. These equations equal to K divided by K minus 1. K stands for the total number of questions, then multiplied by a bracket 1 equal within the bracket 1 minus the sum of the variance for each individual questions divided by the variance for the total score. Here in Spss, I have a data extracted from an exam result for 10 students answering 15 multiple choice questions, and the score for each question is recorded as either 1 or 0. 1 stands for correct answer, 0 means wrong answer. So these data here are dichotomous data. That means a binary data, only two options, correct or wrong. And to determine whether these tests that have these questions in it are reliable, so we're going to do reliability tests based on the Cronbach alpha and based on the formula just described shortly. And to do the test, the first step is to calculate the total score achieved by each individual participant or student, and that can be done by combining all the scores for the 15 questions answered by each individual student. And to do that is to click on transform, compute variable, and then in the window for target variable we're going to call it total score. And the total score is the sum of all the scores achieved by each individual student. And to use the command for the sum, we will click on the function group all, scroll down to statisticals, and then in statisticals select the command or the function for the sum. Drag the sum to here, to this numeric expression box, and then insert the variable one by one between those brackets separated by comma. So we're going to insert the first variable and then separated by comma the second variable, and then comma a third variables, and so on until we insert the whole variables that we want to add or combine together. So we need to make sure that we keep the separate the variables with a comma when we enter them. Another comma here. 11, question 11, 12. So we need to make sure that there is always a comma between variables. Right, so if we click on OK, a new variable is generated in a column for a new variable is generated in Spss, and I'm going just to do some editing on this variable by clicking on the variable view, and then I'm going to decrease the decimal point to 0, and I'm going to convert that measures into scale, and I'm going to center that, make it into the center, and I'm going to reduce the column into 4, so to make it neat and tidy. So now we have calculated the total score for each individual student participated in the exam, and following the alpha equation here, Cronbach alpha, we need to calculate the variance for the total score. And to calculate the variance for the total score for this variables, we click on analyze, scroll down to descriptive, click on frequencies. In the frequencies we are going to determine the variance for the total score, so we drag the total score to the variable box, click on statistics. In the statistics box we're going to select the variance, click on continue, as we're only interested in the value for the variance. An output from Spss generate two tables. One of the tables says that we have 10 participants and the variance for the total score is equal to 24.84. So if we double click on that and then highlight that and select the numbers, copy, and then bring it here to this PowerPoint, and I'm going to place the variance for the total scores in this place here, and I'm going to decrease this by 1 decimal. So we have calculated the variance for the total score. The next step is to calculate the variance for each individual questions and then add them together. To do that, here in this SPSS, we're going to select the data and do a transpose to calculate the variance for each individual question. And the way to do that is to click on data, transpose, and on this small window select Control A, select all and transfer them into the variable box, and then click on OK, and the data has been transposed in a way that all the questions now are in rows and all the students are now in columns. So I'm going to do a few editing here before I proceed with the further calculation. So what I will do, I'll click on the variable few and I'm going to decrease the decimal into 0. So I'm going to make all the values for 0 decimals, and I'm going to change the measures for each variable to scale. Every one of them, make it scale. And then I'm going to center the data into the center of the columns. So selecting this and then all centers, and I'm going to decrease the column width into, make it 4. And another modification I'm going to do is also rename the columns for the students. So to do that is to click on Control F and use the replace function, and I'm going to type VAR0 and replace that with S for students, and I'm going to do that for all the variable. And to do that, I first have to select all the variables, click on replace all, so all the variables has been renamed. Click on close, back again to data view. Now the data looks more neat and tidy. So now we have already calculated the variance for the total scores. Now we need to calculate the variance for each individual questions here, from question number 1 to question number 15. And the way to do that is to click on transform, compute data, and then we're going to call that the variance for the questions. So variance for each questions. And to do variance for each questions, we're going to select the command variance from the function group. If we click on all and then scroll down to statistical, and then in statistical, in the box below, select the variance, drag the variance into the numeric expression, and again we are going to calculate the variance for each individual students. So we're going to use for each individual questions, and if we're going to use the variables from student number 1 to 10, and the way to do that again is to insert the first variable and then separate it by a comma, and we do the same for the rest. Until we reach the S10. If we click on OK, a column will be generated for the variance for each individual, calculated for each individual question. And I'm going to do some editing here for variance, is to make it center and make it scale and reduce the decimal into 0. So I'm going to get rid of this value for the totals. I'm going to keep the decimal by 2, as we are here we're having decimals, so we'll retain the decimals, 2 decimal points, so we can see the variance here. This is the variance for each individual questions. Now we need, following this formula here, we need to add all these variance for each individual questions together, and the way to do that is to click on Analyze Descriptive Frequency, and there we're going to select the variance for questions, drag it to the variables, click on Statistics, and then select the sum, because we are going to add all the variance for all the questions together. So if we click on Continue, then click on OK, again the variance for the 15 questions has been calculated and found to be 3.8, and I'm going to select this, or select this, copy it, and or just type it here, 3.8. Now we have most of the component required for calculating the Cronbach alpha ready. So the next step is to divide these figures to find out the product. So to do that, I'm going to use a calculator here. Using the calculator to divide 3.8 over 24.84 equal to 0.152 or 0.153. Then subtract this figure from 1. 1 minus 0.153 equal 0.847. 0.847. Then multiply this figure with k, which is the total number of questions, divided by k minus 1, which is 14, and the total number of the questions are 15 here. So 0.847 multiplied by 15 divided by 14 equal to 0.9 or 0.91. So this figure, or alpha value of 0.91, means that the test or the exam is 91% reliable, or 0.91 reliable. The value for the alpha or the Cronbach's alpha range from 0 to 1. 0 means that the test or the exam is not reliable, and 1, it means that the exam is extremely reliable. So in this case, 91%, the exam is reliable. So this is the way to perform reliability tests in SPSS for a multiple choice question exam using the formula or the equation for the Cronbach's alpha, which is equal to k divided by k minus 1 multiplied by 1 minus the sum of the variance for each individual questions divided by the variance for the total score to get the value for Cronbach's alpha. So Cronbach's alpha is one of the method to evaluate the exam, the multiple choice exam questions quality. Cronbach's alpha in SPSS is one of the statistical methods that can be used to measure the internal consistency of items or score consistency. Cronbach's alpha value can be calculated to determine the reliability of multiple choice question exam paper. The value for the Cronbach's alpha range from 0 to 1. 0 means that the exam or the test is unreliable, and 1 means that the exam paper is extremely reliable. Here in SPSS data view, I have data taken from exam result for 10 students answering 15 multiple choice question, and the score for each question is recorded as either 0 or 1. 0 means wrong answer, 1 means correct answer. So the data here we have is a dichotomous data, i.e. binary data. There is just only two options, either right or wrong, 0 or 1. To determine and find out whether the exam is reliable, we need to calculate the Cronbach's alpha. And to do that, click on Analyze, scroll down to Scale, and then select Reliability Analysis. Click on it. In this new window, we're going to select all the variables of the questions from 1 to 15. Select A and then drag them and place them in the items box. And for the model, we are going to use the alpha, the Cronbach's alpha. In the statistic section or icon, a new window will, if we click on it, a new window will appear, and we are going to select the scale from the descriptive scale if item is deleted, and I will shortly describe the benefit of choosing this option. In addition to that, I'm going also to select the if test, and if I click on continue, then on OK, the SPSS will generate an output with few tables on it. The first table summarizes the case. So we have here 10 students, and the second table is the important table, as the SPSS package has calculated the Cronbach's alpha, and it was found to be equal to 0.91, so or 91%. So what does this value mean? This means that the test or the exam is 91% reliable. So any value for the Cronbach's alpha equal to 0.9 or greater is considered to be an extremely reliable exam, and anything close to 0 it means unreliable. So for this exam, the reliability is very, very high, and the test is consistent and excellent. In the third table here is very interesting table. It shows each question number 1 to question number 15, and in the third column here it shows corrected item for total correlation, and then the next to it Cronbach's alpha if item is deleted. So what does that mean? If question number 1 is deleted, the Cronbach's alpha will increase from 0.90 or 0.91 to 0.92. So this table shows that deleting question number 1 will increase the reliability value or the Cronbach's alpha. To test this, we're going to repeat the same analysis, but in this case we are going to deselect question number 1. So if we deselect question number 1 and repeat the same analysis and click OK, again we can see here we have exactly the same student number, but the questions or the number of the items has decreased from 15. In the above it was 15 questions, decreased into 14 as one of the item or the question has been removed from the analysis. And looking at the Cronbach's alpha value, it increased to 0.92 from a previous value of 0.91. So deleting question number 1 has improved the reliability and increased the Cronbach's alpha. So this is one of the way to calculate the reliability value and Cronbach's alpha in SPSS. If we go back again to the same set of variables, 15 questions and 10 students, if we look at this table that is labeled ANOVA, again in this ANOVA we can calculate, or I can calculate, the Cronbach's alpha. The important values to look at is the mean square. The mean square between individuals and the residual. The residual is the error. So to calculate Cronbach's alpha from this table, you're going to use a calculator. So in this calculator I'm going to use this equation: 1 minus, move this to the right here, 1 minus the value of the error residual 0.153, and then divide that by 1.65. So we're going to use the mean square for people and the mean or the mean square for error, dividing the residual by the between for the mean square of both. And if we click on equal, a value is generated which is 0.905 or 0.907, which is similar to the one calculated by SPSS in this table here. So we have here now two approaches to calculate the Cronbach alpha, that automatically generated by the SPSS or indirectly through using the ANOVA table here to work out the Cronbach's alpha. So this is the way to determine and calculate the Cronbach's alpha in SPSS and to evaluate an exam paper that contains only multiple choice questions, and to determine whether this exam is reliable or not based on the value obtained from the statistical analysis. 3 ways to test reliability of exam questions: multiple choice questions, exam paper, in Excel. The first method is Kuder-Richardson Formula 20 KR-20 equation. The second method is Cronbach's alpha formula. The third one, determine the reliability using the ANOVA table in Excel. Reliability test for multiple choice question exam is one way to measure the internal consistency of items or the score consistency. If a same group of students repeated an same exam with the same question or questions, multiple choice questions at different occasions or different time or different date, and the score for each individual student is similar in both occasions, then the score is consistent and the exam or the test is reliable. Reliability test can be performed in Excel using Kuder-Richardson Formula 20, abbreviated as KR-20. As shown on the equation here, K stands for total number of questions, summation of P multiplied by Q. P stands for proportion of the correct answer for each question. Q stands for proportion of wrong answer for each question, divided by the variance for the total score. Here in this data sheet in Excel, I have a data from an exam result for 10 students participated in the exam and answered 15 multiple choice questions. The value or the score for each question was recorded as either 1 for correct answer or 0 for wrong answer. And to find out whether this exam or test is reliable, KR-20 will be calculated. So reliability test will be performed as shown here in this equation. The KR-20 equals to K divided by K minus 1 and then multiplied by 1 minus summation of P multiplied by Q divided by the variance for the total score. So the first step to do the reliability test is to calculate the total score. So if we type here a label for this column, total score, and to calculate the total score is to add all the values for each individual participant together. And if we click on the symbol for sum and then select the range of the questions from Q number 1 to Q number 15 and then click on enter, a total score for each student is recorded. To calculate the total score for the rest of the student, click on the cell here, hold, drag, and until you reach the last student. So the Excel will auto calculate and auto fill the total score for each participant. So now we need to calculate the variance for the total score, and to do that we select this cell here and then insert the equal sign and then type VAR for variance. Select the first one and then select the range of the data to calculate the variance for. Click on enter a variance of 22.36 is produced. The next step now is to calculate the P and the Q and the summation of both. So here in this cell I'm going to type P for proportion of the correct answer for the first question, and to calculate the proportion of the correct answer for question number 1, can use the mean, because it is calculating these, the correct answer, dividing them by the total number. So we can use the mean here. If we click on the symbol here and select the average here mean represent the mean, and select the range of the data, the scores for question number 10, and click on enter. A P proportion value is generated for the first questions, showing 0.3 as 3 correct answer divided by 10 equal 0.3. To calculate the P value for the rest of the question, select the cell here, hold, drag to auto calculate and auto fill the value for each question. Now to calculate the proportion of the wrong answer for each question, I'm going to type Q here, and then in this cell I'm going to instead of counting the wrong answer and then dividing them by the total number of students, and I'm going to insert in that cell equal sign, then 1 minus the P value here of this cell, selecting this cell, and then click on enter. A Q value is calculated. Again, to auto fill and auto calculate the Q for or for the rest of the question, select, hold and drag to auto fill and auto calculate the value. So here we have the P value, the Q value. And now we need to multiply P by Q. And the way to do that is select the cell here, insert equal sign, and then select the P, the cell for the P for the first question, and then multiply that using this symbol, multiply that by the Q, selecting the Q value for question number 1, and then clicking on enter. PQ is calculated for the first questions, and to calculate the PQ for the rest of the questions, hold, drag, and the Excel will autofill and auto calculate the value. Now we have the PQ for every questions, and following this equation we need to add them up, all these values together. And to do that, click on this cell and then select the symbol for sum and select the range for PQ for question number 1 to question number 15, and click on enter. A value of 3.42 is generated. So now we have most of the component to fill and calculate the KR-20. So here we have the K, we need the K, we need the summation of P by Q and the variance for the total score. For K, as I said, we have here 15 questions, so K value is 15. The summation of P multiplied by Q is 3.4, so I'm going to click, select, and then copy, and I'm going to paste this using the this paste. And for the variance of the total score, we have the variance here for the total score. I'm going to right click, select copy, and then place that in this cell as we saw here. Now to calculate the KR-20, I'm going to use this cell, insert in it equal sign, then open a bracket, and then multiplied that by another bracket to place the equation using this equation here. So in the first bracket, I'm going to add the k value. The k value is 15 divided by 15 minus 1 equal 14. So I'm going to divide that by 14. And in the second brackets, I'm going to add 1 minus the summation of p, multiplication of p by q. So selecting this. Once the value for the summation of p multiplied by q is inserted, need to divide that by the value for the variance of the total score. Selecting this cell and pressing enter, a value for KR-20 is calculated and it is equal to 0.91. This value means that the test or the exam is 91% reliable. So if we look at the table here, which shows the range for the KR-20 values and the measurement of reliability and labeling of the reliability, anything that is equal to 0.9 or greater is considered to be an extremely reliable test or an exam. A value for KR-20 from 0.8 to 0.89 is considered to be good for reliability. Anything in the range of 0.7 to 0.79 considered to be acceptable, and the range of 0.6 to 0.69 is considered to be questionable. KR value for a test that has a range of 0.5 to 0.59 is considered to be a poor test, and a test with or an exam with a KR-20 value of less than 0.5 indicates that the exam is unacceptable or unreliable. So the KR-20 value ranges from 0 to 1. 0 means that the exam or the test is unreliable, and 1 indicates that the exam is extremely reliable. So this is the way to determine whether an exam or a test is reliable or not, by using the KR-20 formula and determining the value using the equation. Reliability test for multiple choice question exam in Excel using Cronbach alpha. Reliability test measures the internal consistency of items, i.e. the scores consistency. If a group of students, the same group of the students, repeated the same exam, the same questions at different occasions, their score or scores for both occasions are similar, and that indicate that the exam or the test is consistent and reliable. And the way to calculate the reliability of an exam as a whole or a test is to use the Cronbach alpha. This is one of the method for reliability test, and the equations for that is as given here. Alpha equals to k divided by k minus 1, as k represent the total number of questions. This multiplied by 1 minus the sum of the variance for each individual question or item. divided by the variance for the total score. Here in Excel data sheet, I have a data extracted from an exam and a test for 10 students answering 15 multiple choice questions, and the score for each question was recorded as either 1 or 0. 1 stands for correct answer, 0 stands for wrong answers. So these data are dichotomous data, binary data, just two options, correct or wrong. And to determine the reliability of the exam as a whole, we're going to use the Cronbach alpha equation to generate a value for the alpha. A value of the alpha does range from 0 to 1. 0 indicates that the test or exam is unreliable, and 1 indicates that the exam or the test as a whole is extremely reliable or excellent. The first step in calculating the reliability is to calculate the total score achieved by each individual participant or student. In this case, i.e. to add all the scores achieved by each individual student. And the way to do that, in this new cell, we're going to label this cell or this column as total score, and to calculate the total score for each individual participant, select the cell, then select the sum symbol here, and select the range of the data to combine and add from question number 1 to question number 15. And if we click on enter, the total score for the first student is calculated. To calculate the rest of the scores for the rest of the student, we're going to select the value here, hold, drag to the last student, and the Excel will auto fill and auto calculate the value for the total score for each individual participant. Now we have calculated the total score achieved by each individual participant. The next step is to calculate the variance for the total score, i.e. the variance for these scores. So if we select this cell and then insert the equal sign and then type VAR for variance and select the first options here, and then select the range of the data to determine the variance for, and then click enter, a value of 22.36 or 36 is generated. So this is the variance for the total score. The next step is to calculate the variance for each individual questions. So each one of these questions, Q number 1 to Q number 15, we're going to calculate the variance for those variables. And again, it is the same concept. If I'm going to type here variance and then select this cell, in this cell I'm going to insert the equal sign and then type VAR, select the first option here, and then select the range of the data, select the range of the data for question number 1 to determine the variance for it, and click on enter. A value for the variance for the first question is calculated. To calculate the variance for the rest of the questions, just click on the value here, hold, drag to auto calculate and auto fill the value for the variance for each specific questions. Now we have calculated the variance for each questions. The next step is to add them all together. So what I'm going to do here in this cell, I'm going to select this cell, then select the sum as I'm going to add them, and then select the variance for the 15 questions. And if I click on enter, a value of 3.42 is generated. This is the value for the sum of the variance for the questions. Now we have most of the component of this formula ready. For the K represent the number of questions. So here we have 15 questions. And for the variance for the total score, we have calculated that to be 22.336. Just click, right click, copy, and then we're going to paste this value using this option here. So we have now all the component for the formula ready. The next step is to calculate the alpha value. And the way to do that is to insert the equal sign and then open one bracket multiplied by the second bracket, and in the first bracket I'm going to add the K. The K is 15 divided by 15 minus 1 is 14, so I'm going to divide that by 14. And then in the second bracket here I'm going to add 1 minus the first value of the sum of the variance for the items, selecting this value here and then dividing that by the value for the variance for the total score and clicking the enter key. A value of alpha equal to 0.908. So this value means that the exam or the test is 91% reliable, and that is a good result and good value. So here if we look at the table, we can see that Cronbach alpha value has different ranges, and each ranges will be represented by reliability. If the alpha value is equal to 0.9 or greater, then the reliability is excellent. If the alpha value is between 0.8 and 0.89, it's a good reliability. A value of 0.7 to 0.79 is acceptable reliability. A value of 0.6 to 0.69 is questionable reliability, and an exam or a test that has a alpha value of 0.5 to 0.59 is considered to be a poor reliable exam. A value of less than 0.5 indicate that the test is unacceptable and unreliable. So this is the way to do the reliability test based on the Cronbach's alpha using the formula given here by calculating the variance for the each questions, adding them together, divided by the variance for the total score. Cronbach's alpha in Excel measures the internal consistency of items and score consistency. The alpha is calculated to determine the reliability of multiple choice question exam paper using ANOVA table. Here in this data sheet in Excel, this data is a dichotomous data taken from an exam result for 10 students answering 15 multiple choice questions, and the score for each question is reported as 0 or 1. 0 means wrong answer, 1 means correct answer. So these data are dichotomous, binary, as there is only two options, correct or wrong answer. And to determine whether the exam paper is reliable, we can calculate the Cronbach's alpha. And to calculate the Cronbach's alpha, click on data, and if you don't have the icon for the data, you can generate that through the options in the file and then select the data analysis icon. Click on data analysis, a window will appear, and we are going to use the analysis tool of ANOVA. ANOVA 2-factor without replication. And if I click on OK, another window will appear, and we're going to select the input range. And to select the input range, I'm going to highlight the range of the data I want to calculate the ANOVA for it. So we're going to leave the alpha as 0.05, and then I'm going to generate the output in a cell as highlighted here, selecting this. And then if I click on OK, two tables are generated in Excel. The first table shows the count, the sum, the average, and the variance for row 1 to 10 and column 1 to column number 15. We are interested in the second table, which is the ANOVA table. And the two important figures we are interested in is this figure, the means square for the rows and the means and the errors. And if I'm going just to highlight these in red. To calculate the Cronbach's alpha, use the following way. In this cell, I'm going to type alpha, and then next to it I'm going to insert equal sign, and then number 1 minus the error divided by the rows, the means square for error divided by rows, and then hitting the enter key. Cronbach's alpha of 0.91 is generated. This figure indicates that the test or the exam paper is 91% reliable. So this table here, small tables, shows the range for the Cronbach's alpha and the reliability. Any value for the alpha equal to or greater than 0.9, then the reliability is excellent. A value of 0.8 to 0.89 indicates a good reliability. A value of 0.7 to 0.79 is acceptable reliability, and Cronbach's alpha value of 0.6 to 0.69 indicates questionable reliability, and the value of 0.5 to 0.59 is considered to be a poor reliability, and anything with a value of less than 0.5 for alpha is considered to be an unacceptable exam or test, i.e. unreliable. So this is the way, one of the way to calculate the Cronbach's alpha and determine the reliability of an exam paper, sorting it out either as extremely reliable and excellent reliability or an unacceptable unreliable exam.